Okay, so in 7th grade accelerated math today, we are going to learn about integer exponents. Your objective for item number 17 today is going to read something about integer exponents. And integer means that it's going to be negative and positive whole numbers, right? Integer exponents. So we are going to be talking mostly about our negative exponents. So your objective should read something along the lines of something that you have, of course, copied from Canvas. It should read something like, I can solve expressions containing integer exponents, which is basically a negative exponent. So there are two exponent vocabulary terms that you should have defined from Canvas, and if you haven't done those yet, you probably should go back and define those so you have an idea of what we're talking about. The first thing we're going to do is, a couple of lessons ago, we talked about integer. We didn't talk about integer exponents. We talked about integer, or just exponents altogether. So I want you to recall these things. Okay, so recall, don't forget that when we have something that looks like this, x and then some number to the side, which is kind of called superscript, we are going to be looking at this, and I am going to be referring to this number here that's high and into the corner. This is called an exponent or a power. So if I say something is raised to a power, or I refer to the exponent, this is what I'm talking about, the one that's high into the corner. Now, if I say the base, I am talking about the number that it is attached to. This part here is called the base. So I want you to remember that when we are doing this lesson. Okay, you also should have recalled this fact. You should have also recalled the zero exponent rule. Remember that x to the 0 is equal to 1, right? We should remember that anything raised to the 0 power is 1. Anything raised to the 0 power equals 1. Those are things that you need to remember during this section, that you need to remember, so that because it kind of becomes important in this section. So we're going to put another squiggly line because that's all that we have for the recall section. And basically, I want you to kind of look before we give you the finalized rule, and I want you to look at the exponents and numbers. And we kind of talked about this in our class, I think, about the zero rule. We're going to start by talking about it with twos. So if we have 2 to the 4th power, that is equal to 2 times 2 times 2 times 2. So 2 times 2 is 4, times another 2 is 8, times another 2 is 16. Okay, and then we have 2 to the 3rd power. We have 2 times 2 times 2, and that's 3 2's. So 2 times 2 is 4, times 2 is 8. Okay, we're going to go down another power. We're going to say 2 to the 2nd power is equal to 2 times 2, and 2 times 2 is, I'm going to line them all up so it's more helpful to see. We have 4. If we go down another power, we have 2 times nothing, right? Just 2, and that's going to equal 2. Okay, and if we go down a power, well, let's see what happens. We're going to look at the relationship between the things that just happened. Look, remember we talked about this? These two we divided by 2 when we went down, and then we divided by 2 when we went down. We divided by 2 when we went from here to here. And so in order to go from this one here, we're going to need to divide by 2 again, and 2 divided by 2 is just going to be 1. Okay, so now if we're going to go down even further into our negative exponents, because we're going to go down 1, that means we're going to need to divide this by 2, so that's going to equal 1 over 2, right? Because as you saw, we kept dividing it by 2. And then the next one, if we say negative 2 divided by 2, well, we're going to say, okay, that becomes 1 over 2 divided by 2. So that's a crazy fraction, right? But that's, if we have to do the copy dot flip, that's the same as saying 1 over 2 times 1 over 2. That divides it, right? So that becomes 1 over 4, which is interesting. Look at that. We have the 2 to the negative 2 power, but now it's in the bottom. Well, let's see if that happens with 2 to the third power. So we have 2 to the third power is equal to, that would make it 1 over half times 1/2, and then times another half, right? Which is equal to 1 over 8, which, big surprise, is the same as, oops, that's a negative third, sorry. It's the same as 1 over 2 to the negative third power would be here, right? Because it's never going to be simple. We always have to get rid of that negative exponent. So the algebraic rule about negative exponents is anytime we have x to the negative n power, remember we talked about there's the imaginary 1 here, okay? So we're just going to flip the exponent, the base and the exponent, into the denominator. And we're going to put the 1 on top. Basically, we're going to make it a reciprocal. But this makes it a positive exponent. Because you can see when we did all of these, as we went down, basically we just flipped the thing into the exponent, right? That's how it became a -1. So then if we look at things like, if we look at, say, x to the negative third power, we're just going to flip it down and say 1 over x to the third power. Or if we have 5 to the negative fifth power, that is going to equal 1 over 5 to the fifth power. Or if we have 10 to the negative 2 power, that's going to be 1 over 10 squared, right? So anytime we have a negative exponent, we're going to flip it into the denominator. But what if it was in the denominator? Then we're going to flip it to the numerator. So wherever it is, we're either going to flip it up or flip it down to get rid of that negative number. Okay, I am running out of paper, as you can see, so I'm going to flip it over and I'm going to go over some more examples, and hopefully that will kind of give you a little bit of an idea of what we're going to do in the homework and in the quiz. If you need to pause, go ahead and do that. Otherwise, just flip with me. Okay, this was still item number 17. And we're going to continue with some examples. And let's do one like the one I was just talking about. Let's say that we have 1 over 10 to the negative third power, right? Well, to get rid of that negative, we're going to just do the exact opposite. We're going to flip it, instead of down, we're going to flip it up. So it becomes 10 to the third power, which is just 10 times 10 times 10, which is equal to 1 with 3 zeros, which is 1,000, right? That's our first example. How about another example? What if we have 10 to the negative sixth power? That's going to equal 1 over 10 to the sixth power, right? Because we had to flip it. And that's going to be 1 over 10 times 10 times 10 times 10 times 10, 1, 2, 3, 4, 5, times 10, 6 tenths, which is equal to 1 over 1 with 6 zeros, which is 1,000,000, right? All right, let's try another. We have -3 to the negative fourth power. Well, first we need to flip it, right? So 1 over -3 to the fourth power, which becomes 1 over -3 times -3 times -3 times -3. Okay, -3 times -3 is 9. -3 times -3 is 9. So this becomes 1 over 9 times 9, which is 1 over 81. Okay, on the other hand, what had happened if you had -3 to the negative fourth power? Like this. Okay, that would then become -1 over 3 to the fourth power, which becomes negative, and we already knew that was an 81, right? 1 over 81. So you gotta be careful where the parentheses are. Remember that the exponent is only attached to whatever it's touching. Whatever's out here, it's not necessarily attached to, okay? So let's try another one. For 5, we're going to say we have x to the -1, and we're going to solve it for x equals 2. So this would then be plugged in. We're going to take that 2. We're going to plug it into the negative 1. So that becomes 2 to the negative 1 power, which is going to be equal to 1 over 2 to the first power, which is just 1 over 2. And you might even reduce that to a decimal, right? Okay, let's try a couple more, and then you can start with your homework. So that's going to be a to the 0 power, b to the negative 3 power, for a equal to 8, and b equal to negative 2. So we'll have a to the 0 power. So that would make it, if we plug these in, right, we're going to replace the a with an 8, and we're going to replace the b with a negative 2. So we're going to say that that's 8 to the 0 power times negative 2, with parentheses around it, to the negative 3 power. Well, we know that this one is 8 to the 0 power. Remember that rule about 0 powers? Anything to the 0 power is 1. So that's 1. And then this is going to be flipped, so it'll be 1 over 2, negative 2 cubed. So this becomes, we can multiply these guys together to just get 1 over negative 2 times negative 2 times negative 2. Negative 2 times 2, negative 2 is 4, times another negative 2 is equal to a negative 8, so it's negative 1 over 8. Okay? And we're going to do one last one, and then you can get started on your homework. So we have a to the 0 power, t to the negative 3, so this one's going to be super crazy confusing at first, x to the 4th power, and z to the negative 2, r to the 0. Well, let's look at the top first. Okay, a to the 0, that's easy. I can turn that into a 1. I'm going to turn it. Okay, and the t, well, what do I do with the t? I need to flip it down. So I'm going to put t to the 3rd in the bottom. What about x to the 4th? Do I need to do anything to that? No, x to the 4th is as simple as I can get it. So I'm going to put x to the 4th right here, because that's just staying where it is. This stuff's going to be in the top, right? Now let's look at the bottom. Z to the negative 2. Well, it's negative 2, so I need to flip it up, just like we did from the first example. So I'm going to change that to a z to the 2nd power. And r to the 0, remember we talked about anything to the 0 power is 1, so we're going to make that 1. Okay, and then let's just go through and see if there's any more simplification we can do. Well, x to the 4th, z is fine, z to the 2nd is fine, but the 1, if it's multiplied there, we don't really need it, right? So we could just then simplify it a little bit more to x to the 4 z squared over, and I could see this is t3 but times 1. I don't really need to write the times 1, so it's going to be t to the 3rd. Okay, so that's going to be what it is. It's going to be x to the 4th, z to the 2nd, over t to the 3rd. Now, some of these are going to be a little bit harder to write into Canvas because they want you to use the caret button, which is Shift 6. So if I'm going to write this in Canvas, just so you know, okay, I'm going to write x caret 4, z caret 2, and then it's going to have, well, there's not that sign in there, is there? So it's going to be a slash t caret 3. Okay, and where are you going to find that caret? This caret here, well, I'm using orange, how ironic, is going to be Shift 6, and that's how you're going to denote the caret. If you think you've written it, all you've done is written it weird, and the Canvas is telling you have written it correctly, then go ahead and email me, and I'll see if I can fix it. Okay, so go ahead and work on your homework. If you have any questions, email me or let me know, and hopefully you'll have a great time doing this. Remember to do the quiz also.